Hello everyone, today I'll be discussing light bulbs filled with krypton gas. The birth date of the light bulb is considered to be October 21st, 1879, when Edison, after more than a year of intensive experimentation, succeeded in creating a bulb which burned 40 hours. Since then, the light bulb has evolved to a commonplace item mass-produced with a tungsten filament and filled with inert argon gas, which will burn for 750 hours. But based on the research article that I read, Durotest Corporation introduced a new line of light bulbs using krypton gas, which has a life expectancy of 3,000 hours and several other advantages as well. So the three practical advantages of krypton-filled bulbs are operating a filament in a bulb with a krypton will result in a lower heat loss than in a bulb filled with argon. A bulb with a krypton could be made proportionally smaller than a bulb filled with argon, and the filament of the krypton-filled bulb could be run at a higher temperature than the filament of an argon bulb, giving a higher color temperature and a quieter light. The manufacturers, in optimizing these three variables, have produced a product which gives saving in power and size and increased whiteness. So in the article, the way they figured out that krypton is more effective, they considered the elastic head-on collision of two particles moving along the line. And then the velocities after collisions are related to the masses m1 and m2 and the velocities before the collision. So these two represent the equation. So if 2 is the krypton or argon atom and it's assumed to be essentially at rest with respect of 1, a tungsten atom approaching it, the velocity of the tungsten atom after the collision will be determined by this equation. So if m1 and m2 are equal, then the velocity after the collision will be 0 for all the values of velocity 1, which is before the collisions. However, the atoms of tungsten have a mass greater than krypton and argon. So the atomic weight of tungsten is 183.85. So using the atomic weights of all three atoms, they figured out that for tungsten striking argon is 0.64, and for tungsten striking krypton is 0.37. So the more massive krypton is, the more effective in slowing down tungsten atoms and that it is than argon. So one such head-on collision with a krypton atom will remove 86% of the kinetic energy of the tungsten atom. So afterwards, the tungsten atom moving slowly has a much greater chance of colliding with the filament surface again and being rebounded to the solid. So the gas acts like a blanket, decreasing the rate of diffusion and reducing the rate of evaporation of the filament. So this is why krypton is more effective for this purpose than argon.